Okay, welcome to lesson 2, multiplication properties with exponents. If you remember back when you were first taught about what exponents were, you might remember that an exponent is simply a simple way to write multiplication. In other words, if I have x times x times x, you learned that I could rewrite that as x to the third. Okay, or vice versa, that x to the third meant x times x times x. Okay, well, that might have been where you started off, and that's simple enough to understand. But let's look at something where maybe I have x to the third times x to the second. Well, before we try to tackle that, let's go back here to these guys. If I remember back to the first lesson, 0 and 1 exponents, an exponent always exists. If it's not written, it's generally, let me do that in a different color. It's generally a 1, because anything to the first power is just itself. So we normally don't write the 1s. So if I see this, what's going on with these exponents to give me a 3? Keep that in the back of your mind real quick. Now let's go down to here, the other problem that I wrote. X to the third times x squared. Well, let's write it down in expanded notation, maybe the way you may have been shown before. X to the third is just x times x times x. Okay, that takes care of this right here. I've got to take care of this multiplication, goes right here. And then I have also x squared, which is x times x. Well, back when you first learned this, if I have x 5 times, how do I write that? Well, x to the 5th power. So, how do I get from here to here? Remembering that if I don't write the exponent, it's always assumed to be a 1. Well, let's see. 1, 2, 3. 1, 2, 3, 4, 5. All these added together give me 5. Well, this plus this, if the base is the same, will give me x to the 5. So, looking at this pattern, now, in order for this to work, the base has to be the same variable, or the same number. If it's a different variable, this product rule doesn't work. Has to be the same base. In other words, I can't have x to the second times x to the y, because, well, I wouldn't have some students are tempted to think, okay, the exponent rule is addition, so they might write that answer as x, y to the 4th or something like that. Well, if I draw this out, that's x times x times y. And if I drew this out right here, that's just x times y times y times y times y. Well, part of the deal here is that's an equation. That means this has to be the same as this. That doesn't work. So simply stated, if I have two different variables and I'm adding or I'm multiplying, well, the exponent stays the same. That's just going to be x squared, y squared. Okay? Now we're not going to deal too much with these type of problems right now. We'll get to that a little bit later. Let's just focus on the main skill. I just wanted to point that out. So, looking at the pattern and what happened, I'm going to set up a general rule. If I keep the base x and I just add up all the exponents, that's going to give me x to the third. here the base is the same. They're both x's. So I add the exponents. 3 plus 2 is 5. So my general rule, a to the n times a to the m equals a to the n plus m. I'll write that out a little bit better in the next slide. So the bases are the same, so I simply keep the same base and I add the exponents. Okay, let's try a couple examples and see. Okay, I neatened this up a little bit so that it was all in line. Notice I used, instead of just n, I used an m. These just represent the fact that the exponents can be any number. Okay, the important thing is that the base has to be the same here in order for this to work. So if I have a problem similar to, let's use variables first, x squared times x to the fifth, well, the base is the same. That's the first thing I want to do. I want to identify that. So my base is going to come out the same on the other side. And then I'm going to have 2 plus 5. Or I could write it out like that. 2 plus 5, which is x to the 7th. Okay? Now you try one. Okay. So take a look at this. I have y to the 3rd power times y to the 6th power. Identify the bases, add the exponents. This is multiplication. Stop the video, write out what you think it is, then check your answer back in a second. Okay, bases are the same, so this property works. Base stays the same, and I add the exponents. Final answer is 9. Y to the 9th. Now, I don't expect when you're doing your work to necessarily see this unless you think you need to. This little part right here, you'll probably just do in your head. Okay? Now, the same thing works if I have a negative exponent too. Okay? So, here I have y to the 4th times y to the negative 3rd. Well, the important thing is the bases are the same. So I write the base out. Well, let's write this out longhand. I just add the exponent, so it's 4 plus negative 3. Well, you can do that. 4 plus negative 3 is just 1. And if you got this far, I'd be pretty happy. But we can simplify that. We usually don't write the 1. Okay, it's kind of understood. Okay. So you treat them just like regular integers. You add them. Boom, boom. Gives me 1. Okay. Now, I'm going to throw a little loop at you. Watch this. Okay. Again, same type of problem. Y to the 4th times y to the negative 6th. Alright. Well, base is the same. I get 4 plus negative 6. That's y to the negative 2. Alright. So a lot of students may be tempted to stop right there, but hold on. We know that negative exponents shouldn't be in an answer. I can simplify this further. This goes back to our negative exponent rules in one of the last lessons. If it's a negative exponent and it's on top, this guy's up on top, he's going to go downstairs. Remember, there's a 1 out front there, so the 1 stays, and the exponent changes to a positive. Okay. Again, this is only partial answer. This would be the full simplified version. So be mindful of that. If you get an answer with a negative exponent in it, you need to take care of this negative exponent. All right. One last problem. Okay. 2 to the 3rd. I've just got numbers for bases. I treat them just like I have before. 2 to the 3rd times 2 to the negative 5th. The important thing, the bases are the same. So I keep the base, and it's 3 plus negative 5, which gives me 2 to the negative 2. Now what have I got to watch out for? This is good, but there's a negative right there. So let's take care of that guy. final answer. Okay? So, you got about 4 problems on your entrance ticket. See what you can do with those, and I'll see you tomorrow.